All right, so we're given if z is equal to 3 times the cosine of pi over 9 plus I sine of pi over 9, and w is equal to 5 times the cosine of 5 pi over 9 plus I sine of 5 pi over 9, find z times w. So what form is this in? We had 3 forms we learned about yesterday, right? What form is this in? Polar form? Okay, so what I want us to do, and this will be given to you guys on a test or a quiz or your homework, it'll tell you guys which forms I want you guys to write your answers in. So we want to express our answers in polar form and exponential form. So in order to do this, z times w, we had a formula. Whenever we're multiplying two complex numbers, the formula is going to be R1, R2 times e to the I times theta 1 plus theta 2. So R1 and R2, those are just our radii. Okay, so that's the number that's in the very front. So do you guys see how we have a 3 in the front and a 5 in the front here? So multiply those. What's 3 times 5? 15. So I'm going to write down so we have it in our notes. So 3 times 5 times e to the I times theta 1 plus theta 2. So this will always happen in these problems. You guys see how it's the same angle, same angle? And then this right here, it's the same angle and the same angle. So this would be your theta 1, and then this would be your theta 2. Okay, so this would just be pi over 9 plus 5 pi over 9. If I add those together, do you guys agree that's 6 pi over 9? But that reduces. What does that reduce to? 2 pi over 3, good. So this is just going to be 5 times 3 is 15, e to the I times 2 pi over 3. So this right here is our exponential form. So this is our answer. Okay, now if I want to write this in polar form again, for polar form, this is pretty easy. Z is equal to R times cosine of theta plus I sine theta. So from this answer, guys, what's R? 15. And what's theta? 2 pi over 3. So you just literally just plug it in. So Z is equal to 15 times cosine of 2 pi over 3 plus I sine of 2 pi over 3. And that's it. Now, just to see if you guys understand what's happening, we could figure out what this is, right? That's just a value on our unit circle. And same thing here. Couldn't we figure out what that is? What would happen if I did that and then distributed the 15? What form would that give me? Remember, there's a third form, right? What? Rectangular form. Because then that means I could plot that on the coordinate plane. So does that make sense, guys? From this answer, you can get any answer very fast, okay? So it just depends on what they're asking you. So we're only halfway done with the problem. because we want to also find part B, Z over W. So from our definition yesterday, when we multiply two things with the same base, we add the exponents. So now since we're dividing, the only difference is we're going to subtract. So Z over W is going to be equal to R1 over R2 times e to the I times theta 1 minus theta 2. So it just depends on the order they give it to you guys. R1 in this case is the first radius, so that's going to give me 3. R2 is just 5. Times e to the I times theta 1 was pi over 9 minus theta 2 was 5 pi over 9. Okay. So if I simplify this, this is going to be 3 over 5 e to the I times. If I subtract these, what would that give me? Good, negative 4 pi over 9. Now, we could stop there if this is an angle I'm allowed to use. From our definition, am I allowed to use this angle? What were we told theta has to be between? 0 and 2 pi. So what could I do to this angle to get a coterminal angle? Add 2 pi. So I just have to add 2 pi to this angle to make it so it fits my little range I want. So do you guys agree if I get a common denominator? 2 pi is the same thing as 18 pi over 9. Does that make sense? Julian, you with us? If I add those together, what do I get? What? Yeah. I thought you said it, but okay. Cool, is everyone cool with that? Now so remember this, what form is this? Exponential form. So if I want to write it in polar form, the only thing I need from this answer for polar form is my angle and my R. So the polar form, there's no work to show for this, guys. If you know the form, just plug it in. Polar form is Z equals R, which is 3/5, times the cosine of the angle plus I sine of the same angle. So I'll just write that down for all our listeners at home. R, theta, and then that's all you need. Cool. Questions? All right. Abraham de Moivre. And if anybody's listening to this on the internet and I say it's lame wrong, please don't judge me. R.I.P. Because I don't think he's alive anymore. Okay. So what this guy discovered is if we're given a complex number that's written in exponential form, if we want to raise it to a power, so if this is z, if I take z and raise it to some power, it's the same thing as taking the complex number. So it's going to be r times e raised to the I theta if I raise that to the nth power. We can treat this and the r separately. So if I raise r to the nth power, do you guys agree that's just going to be r to the nth power? Okay. What's the rule if you take an x or a base and you raise it to a power? What do I do with the powers? Multiply them. So this is going to be the same thing as times e to the I times theta times n. And this will make more sense when we do it with like actual numbers. So if you guys can do me a favor, highlight this and highlight this. Okay. So let's go ahead and put this into action. So if I'm given this complex number, express z is equal to 2 times cosine of pi over 9 plus I sine of pi over 9 cubed in exponential form and in rectangular form. So just remember that exponential form is z equals r times e to the I theta. But the only difference here that we haven't seen yet is I have to take this number and I have to raise everything to the power of 3, right? So what I need to do is I'm taking my z and I'm cubing it. So it might be easier, guys, to write this in exponential form first. So what's my theta? Pi over 9, right? And then my r is 2, right? So it's going to be z is equal to 2e to the I times pi over 9. But do you guys agree I'm taking both sides and I'm cubing it because that's what the problem's asking me to do? Is everybody cool with that? Does that make sense? So then z cubed is going to be, what does my rule say I need to do? Do I just leave this as 2? What do I have to do with the 2? Cube it. What's 2 raised to the third power? That's just 8 times e raised to the I times, what do I do with this number and the power of 3? Multiply them. Pi over 9 times 3 is pi over 3. Because pi over 9 times 3 would be 3 pi over 9. And 3 pi over 9 reduces to pi over 3. Okay? Remember, what are you guys allowed to use on these problems? You can use a calculator to check your work. Okay? So guess what? This is my answer. Okay. So now I want to write this in rectangular form. So going back to yesterday, z is equal to x plus yi. That's rectangular form. If you have your answer in polar form, it's really easy to write this in rectangular form. So what I would do is, even though it doesn't ask us to write this in polar form, I would express this in polar form first, because then all I would have to do is just distribute the 8. So just write that in your notes. Find polar form first. So remember, for polar form, it's z is equal to r times cosine theta plus I sine theta. What was r according to our answer above? 8 times cosine of our angle, which was pi over 3, plus I sine of pi over 3. So this is polar form. So now all I have to do is just think about my unit circle. What is this on my unit circle? 1/2 plus sine of pi over 3. Square root 3 over 2. Don't forget the I. And then if I just multiply both of those by 8, half of 8 is 4, plus when I multiply 8 times this number, the 2 and the 8 cancel. So this just becomes 4 square root 3 I. Okay. Questions? Okay, here's a weird one. So exponential form is z equals re to the I theta. Rectangular form is z equals x plus yi. Okay. So if I want to write this in exponential form, do you guys agree that I need to know what r is and what theta is? Okay? And that's even before I deal with this fifth power. So what I want you guys to understand is this right here, can we think about this as x plus yi? Does that make sense? So x is going to be 1, and the y coordinate is also 1. So how do I figure out what the radius is? Do you guys remember from yesterday? It had a special new name that we called it. Say it again? The modulus of z. Good. The modulus, for those of you guys that were gone yesterday, the modulus is the same thing as, it's called the magnitude, which is also the radius. They all mean the same thing. Okay, that's what, I remember when I took these classes, I was confused because I was like, what does that even mean? They all mean the same thing. So find r and theta first. So r is equal to what we call the magnitude of z. And from the first section of our notes, to find r, do you guys remember it was just the square root of x squared plus y squared? So we can kind of think about this right now. This right here is kind of like rectangular form. So that means x is just going to be 1 squared plus this coefficient right here is also 1i. So it's going to be 1 squared. So it's just going to be square root 2. So this is my r. How do I find theta? I just said it. Tangent. So what's the formula? My coffee kicked in because my brain's working faster than I can speak. Tangent of theta is equal to y over x. What's y? 1. What's x? 1, which is 1. So theta is equal to tangent inverse of 1. Now, you guys got tested on this a couple weeks ago, but again, what are you allowed to use on these? Use a calculator. Your calculator is going to give you a degree measure. What does it give you? 45. But if I want this in radians, that'd be what? Pi over 4. Good. All right. So this is just the beginning of the problem. We haven't even actually done anything yet, because that's just for r and theta. But what does this problem want us to raise everything to? The fifth power. Okay. So in exponential form, z is equal to now r times e to the I times pi over 4. But the problem wants me to raise everything, do you guys agree, to the fifth power? Does that make sense? Can you guys nod so I know you guys are listening? Okay. Even if you guys aren't listening, just fake it to make me feel good. Okay. Now, I would not put this into your calculator, because is this a pretty number? So if you raise this to the fifth power, there's a chance that's going to be really ugly. So what I want you guys to think about is, if I raise this to the fifth power, do you guys agree it's the same thing as root 2 times root 2 times root 2 times root 2 times root 2? What is this? 2. And this? 2. So 2 times 2 is 4. 4 times root 2 is just 4 root 2. Okay? What was the rule when we raise a power to a power? Multiplies. So this is going to just be 4 root 2 times e to the I times 5 pi over 4. Okay. Now to find rectangular form, just like the last problem, you want to find polar form first. So Z is equal to R times cosine theta plus I sine theta. So from above, that's just going to be 4 root 2 times the cosine of 5 pi over 4 plus I sine of 5 pi over 4. So this is going to be 4 root 2 times, at this point, guys, if you guys don't have these decimals memorized, please start learning these decimals because the same ones come up over and over and over again. So what is this number? Positive or negative? Negative. So this would be negative root 2 over 2. But what I'm trying to tell you guys is this value right here, if you put in your calculator, is like 0.701. And then can you also like test this in your calculator, ask your calculator what's negative root 2 divided by 2? That's how honestly I survived pre-cal, is I memorized those decimals and I did okay. Obviously I'm here, right? But if you guys can memorize those decimals, that will help you guys memorize these even better too. So this is also in quadrant 3, so it's going to be negative root 2 over 2. I. That was almost really bad. All right, so this is some funky math. What's root 2 times root 2? 2. What's 2 times 4? 8. 8 divided by 2. So this is going to be negative 4. And isn't this the same number? So if I multiply this times the same number, it's also going to be negative 4, but because there's an I have to remember the I. So this is my exponential form, and this is my rectangular form. All right. Cool. Look at all our beautiful work. Looks cool. Questions? Okay. So for those listening at home and those you guys sitting in front of me right now, when's your quiz? Monday. This problem right here will not be on your quiz, but it will be on your test. Okay, because these problems take a long time. What I'm about to show you right now. Okay. So this has a really weird, like geometric kind of meaning on our unit circle, on our trigonometric kind of plane, our complex plane. You don't have to fully understand what that means right now. But if you guys kind of can follow what I'm saying, then this should make sense. But given that W is a complex number, R times E to the I theta, and that's a complex number, and N is greater than or equal to 2. If W is not equal to 0, there are n distinct roots of W, which is given by this formula. Z subscript K is equal to the nth root of R times E to the I times 1 over N times theta plus 2 pi K, where K is equal to 0, 1, 2, all the way to N minus 1. And I want to say last year when I gave the students this test, yes, I gave them a formula sheet. I'm looking right now. So let me see if I can. I don't want to do that right now. Can you guys remind me when I'm done with the notes? I'll show you guys what the formula sheet looks like. Because if I stop sharing my iPad, it's going to stop the recording. But there is a formula sheet that you guys will be able to use for this test. And this formula is on there for sure. Because I'm your teacher, and even I don't have this memorized. So let's see how this works. So like I said, these problems are kind of long, so just bear with me. So I want us in this problem to find the complex cube roots of z is equal to -1 plus square root 3i. And we want to express our answers in exponential form. All right, so before we even tackle this problem, I want to make sure you guys understand the formula, and if you guys can please nod if you guys are able to follow along. First of all, this gives you a hint of how many times you have to do this process. So when you do a cube root of something, what does that mean? What does cube mean? 3, right? So our n value in this problem is 3. So our formula from the last page was z sub k was equal to the nth root of r times e to the I times 1 over n times theta plus 2 pi k so that means that our formula now is going to be z sub k is equal to, what's n in this case, we said? 3. So whatever we see in n, we're going to plug in 3. So this is going to be the cube root of r times e to the I times 1/3 times theta plus 2 pi k. Now what does k represent? So let's go back to our formula. Our formula says where k is equal to 0, 1, 2, all the way to n minus 1. So what was n in this case? 3. So what would 3 minus 1 be? 2. So we have to do this formula for k equals 0, k equals 1, and k equals 2. Because this number right here, do you guys agree, is 1 less than 3? How many total values do I have right here? 3. So if I do this process 3 times, that will give me my 3 answers, okay? All right, so now we have to tackle this problem. We were given this value. This is in rectangular form. If I want all my answers in exponential form, that's z is equal to re to the I theta. So when I'm given this, do I know what r is right now? No. Do I know what theta is? No. Do I have formulas to find them? Yes. Okay. So r is equal to what? The modulus of z, which is equal to, talk to me guys. Yes, square root of x squared plus y squared. What's x in this case? -1 squared plus square root 3 squared. -1 squared, that's just 1. Root 3 squared is just 3. If you add those together, you get 4. What's the square root of 4? 2. Theta is equal to tangent inverse of y over x. Remember, y in this case was root 3, and x was -1. I just forgot to write this part. Sorry, guys. If I throw that in my calculator, what does my calculator tell me? -60, good. Now, there's a few things wrong with this answer, right? Do I want a negative angle, do you guys think? No. Do I want it in degrees? No. I also have to pay attention to the fact that if I were to graph this number, which quadrant would this be in? Where x is negative and y is positive? Quadrant 2. So this makes sense that it's negative because what's tangent in quadrant 2? Negative, right? So what angle would give me the same tangent value in quadrant 2? So what could I add to this angle to give me an angle in quadrant 2? 360 would give me something in quadrant 4. Pi, right? I could add 180 to get me something in quadrant 2. So if I add 180 to this, do you guys agree that's 120? What is 120 degrees in radians? Two pi over 3. Okay. Is everybody cool with what we're doing so far? So now we have all the information we need to do this problem. So I'm going to use this. And I'm going to use this for my formula. So the formula from earlier was z sub k is equal to the cube root of r times e to the I times 1 over 3 times theta plus 2 pi k. How many times do I have to do this process? 3 times. So all I'm going to do is do it 3 times where k is equal to 0, 1, and 2. You always stop one number before you get to this number. So if it was 7, you'd have to do it 0, 1, 2, 3, 4, 5, 6. Okay, I'm not going to give you guys that on a test. That'd be terrible and mean, and bad for me because I have to grade that. So, all right. So let's see how this works. If k is equal to 0, that means I'm going to write z sub 0 is equal to the cube root of r. What was r in this case? 2 times e raised to the I times 1/3 times, what was theta? 2 pi over 3 plus 2 pi times, what was k? 0. So I want to highlight this and this so that way you guys can see this is going to be the same numbers in every step. The only thing that's going to change, guys, is k. The k value is the only thing that's going to change. So hopefully that makes sense. So this first one's really easy because what's 2 pi times 0? 0. So this just goes away. So this just becomes the cube root of 2 times e to the I times, right here, guys, what is 1/3 times 2 pi over 3? 2 pi over, what'd you say? 3 times 3 is 9. Is that what you said? Okay, good answer. That was weird, I did an oval. Hey, we have one answer. How many more times do I have to do this? 2 more times. So z sub 1 is equal to the cube root of 2 times e to the I times 1/3 times 2 pi over 3 plus 2 pi times 1. Again, the radius and the angle are the same for what we found earlier. And for all of our listeners at home, those are the only things that are changing. Okay, so what's 2 pi times 1? 2 pi. Don't be shy, guys. You guys have a calculator. So if you guys just added 2 plus 2/3, what would that be? 8/3? Right? Okay. 8/3 times 1/3. Did I lose you guys? A pi over 9. Good. So this will just be 8 pi over 9. Cool. Hey, we only have to do this one more time. So when k is equal to 2, z sub 2 is equal to the cube root of 2 times e to the I times 1/3 times theta plus 2 pi times k. And again, these are the same. Only thing that's changing is this guy. So some quick math. This is 4 pi. 2/3 plus 4 would give me 14 pi over 3. 14 pi over 3 times 1/3 would be 14 pi over 9. You guys good? Okay. That's our answers. We're done. What the heck does this mean? So, like I said, you don't have to fully understand this to do this problem. If you guys understand how to plug it in, but you know nothing else about this right now, that's okay. But just to show you guys what this means, we found the complex cube roots of this value, right? This rectangular number from the beginning. What I want you guys to think about is we have a unit circle, right? What you're doing is you're basically taking this number and using it to kind of cut our unit circle into 3 equidistant pieces. So check this out. And if you guys can draw this with me so you guys can kind of understand what's happening. So if you look at our first answer, we had our radius, right? and then times e to the I times this angle. Is that a very large angle? 2 pi over 9? Just so you guys can understand what I'm talking about, what would 2 pi over 9 be in degrees? Ask your calculator. What's 2/9 times 180? 40? So it's little, right? So 40 degrees is something like that. Okay? Our next angle we got was this. You guys with me? How many degrees would that be? So what's 8/9 times 180? 160. So do you guys agree that's right before we're about halfway, so maybe something like that? Okay, and our last answer we got was this. What is this in degrees? $280. So do you guys agree that's just bigger than 270? So I know it's kind of hard to tell, but if you guys just imagine this, doesn't it kind of look like I just took my unit circle and cut it into 3 evenly sliced pieces? That's what this tells you. This tells me that this complex number, if I took this complex number and cut it into 3 roots, it gives me 3 equally apart angles along the unit circle. That's what you just did. So if I ask you guys to find 4, how many slices are you going to make? 4, and they should all be how far apart on the unit circle? Now here's how I know you guys are paying attention. How many degrees is a full circle? 360. How many slices do we create? 3. What's 360 divided by 3? 120. How many degrees was this? 40. What's 40 plus 120? 160. What's 160 plus 120? 280. That's where those come from. So if I ask you guys to make 4 slices, what's 360 divided by 4? 90. So how far apart should your angles be? 90. And it just all depends on what value you're given at the beginning, because that angle will determine where you start, and then it will make your picture a little bit different every time. Okay? Cool? All right, let's do one more. Okay. Okay, this is really mean, because not only how many roots do we have to do? 6. What else do we have to do? That's different. So we have to do a lot of work. Okay, but this is gonna be fun, I promise. So the first thing we have to understand is, what the heck, what do I do with that? This right here is the same thing as z is equal to, is there an I in this number? So can we think about this as 1 plus 0i? So this is like X and this is like my Y. So in order to figure out rectangular form, I need to know my angle I'm dealing with, and I need to know what my modulus is. So the modulus is going to be the same thing as R, which is going to be the square root of x squared plus y squared, which is 1 squared plus 0 squared. Hey, that's just 1. So this is R. To find theta, theta is equal to tangent inverse of y over x. What's y? 0. What's x? 1. 0 divided by 1? 0. Tangent inverse of 0, don't use your calculator. What's tangent inverse of 0? Did you use your calculator? No. What'd you get? 0. It's 0. So that's weird. How's that going to help us? This actually makes our problem easier. Okay, so remember, we're going to use this formula. What is n in this case? 6. So for our problem, n is 6. And then what are the k's I'm going to use? K is equal to what? 0 through 5. Good. And if you're not sure, count them. 1, 2, 3, 4, 5, 6. I have 6. Okay? So for any complex root I'm going to find, z sub k is going to be the form of the the sixth root of 1 times e raised to the I times 1/6 times 0 plus 2 pi k. Now, I'm going to clean this up to make our life a little bit easier. But what's nice about the fact that this was 1 is, what's the sixth root of 1? That's just 1, right? If I take any number and add it to 0, do we care about that 0 anymore? So for our formula, we don't need the 0. We don't care. And the first number is just 1. So it's just going to be 1 times e raised to the I times 1/6 times 2 pi k. So I just need to figure out what all these are when I plug in all my k's. All right. Are you guys following me? Does this make sense? All right, here we go. So when k equals 0, why does it keep doing that? Z sub 0 is equal to 1 times e raised to the I times 1/6 times 2 pi times 0. What is this? 0. What's 1/6 times 0? 0. So this is just going to be 1 times e raised to the I times 0. And I want to leave it like that on purpose because, remember, this is your theta and this is your r. Because our problem wants us to write all of our answers in what form? Rectangular form. What we've learned from our other problems is, what form is it easier to take to transfer it to rectangular form? Polar form. So this problem, who made this problem? It was me. But this is exponential form, right? So each problem we're doing all three forms every time. So this is exponential form. I want to write it in polar form so that way I can write it in rectangular form. So polar form, the only thing you need, guys, is r and theta. So z is equal to r, which is just 1, times the cosine of 0 plus I sine of 0, not theta. What's the sine of 0? You guys are really scaring me right now. 0. So if I distribute this, what's 1 times 1? This is 1. Okay. Hey, 1 down. If I plug in 1, for my simplification from earlier, that means that I'm only plugging in the 1 right there. What is 2 pi times 1? 2 pi. 2 pi divided by 6 is the same thing as pi over 3. Good. So this is my r. This is my theta. So that means that to write this in rectangular form, polar form is going to be z is equal to r, which is 1, times cosine of pi over 3 plus I sine of pi over 3, which is going to be 1 times 1/2 plus square root 3 over 2i. If I multiply these by 1, it's not going to change. So that means my answer for z sub 1 is going to be 1/2 plus square root 3 over 2i. I'm really tempted to show you guys the pattern in the shortcut. Do you guys want me to show you guys this so we don't have to do all the work? Or do you guys want to do all the work? You don't want to do all the work? What was our, how many roots are we taking? 6. What's 360 divided by 6? 60, right? Where did we start our first value? At 0. If I take 0 and add 60, do you guys agree that's going to be pi over 3? Look at your unit circle. If I start at 0, what is the xy at 0? Do you guys agree it's 1 comma 0? That's where that comes from. If I add 60 degrees to that, do you guys agree that's pi over 3? What's the x and y at pi over 3 on your unit circle? Do you guys see that? It's 1/2 comma square root 3 over 2i. The only difference is you're slapping an I to the y. So what would the next value be? So if I take pi over 3 and I add another pi over 3, that would be what? 2 pi over 3? So what would that be? You're not following me? You are? What is the 1 unit circle? What's cosine and sine at 2 pi over 3? Negative 1/2 plus. What would the next theta be? Two pi over 3, that's 120, right? Plus another 60 degrees, what's 120 plus 60? 180. So that would just be pi. What are the coordinates at pi? Negative 1 comma 0, right? So how would I write that in rectangular form? Do I have to put the 0? So what do I just write? Negative 1? Is that what you said? No? Can you guys raise your hand if you guys are following along what I'm saying? Does this make sense? Now, you won't be able to do it like this on every problem because they're going to be kind of funky. Especially like this one. You guys see how ugly those angles were? This will be a little bit harder to do it on something like this. But because these numbers were nice, there's actually a really nice pattern to this. So if I add 60 degrees again, if I think about this in degrees, this was 180, right? 180 plus 60 is 240. 240 degrees in radians is 4 pi over 3. That's in quadrant 3. What do I know about cosine and sine in quadrant 3? Both negative, so it's going to be negative 1/2 minus square root 3 over 2i. How many more times do I have to do this? One more time. So the last one, k is equal to 5. That means theta is equal to 5 pi over 3. So z sub 5 is equal to positive 1/2 minus square root 3 over 2i. Cool. Hooray. And just geometrically, like I said, do you have to know this on the test? No, but it helps you understand it if you guys can kind of visualize this. Our first angle was at 0, right? That was our first answer. Then our next value was at pi over 3. And then two pi over 3. That looks terrible. And then pi. And then down here. And then right here. So this was z sub 0, z sub 1, z sub 2, z sub 3, z sub 4, and z sub 5. It's pretty cool. It's pretty cool stuff.